Hello, my people. Okay, let's go through integration. Here we have definite integral that is a little bit complex that we cannot easily simplify. Here they told us, they are asking us if we have the integral of 6x in brackets 3x squared minus 4 all in brackets to the power of 6, the x that we should integrate with respect to x. Now the problem here is, remember, for integration you need to simplify before you integrate. Now if we have to expand these brackets into 6 places, it takes a lot of time, and there is also a very high possibility of us recording a mistake. And it goes around and it becomes a problem, and you start asking yourself, the mark allocation for this, does it justify that amount of volume of work? But we have other approaches. We can use the chain rule, we can use the U method. For today, I'm going to approach this using the U method. Using the U method. How do we use the U method? Let's go get into it and then I'll explain. What we have to do is, like when we work in algebra, we use the K method for parabolic functions to change when we have complex exponents. That is similar to what we are going to use here also. Now, what do we do? First of all, we take the content of the bracket and we say let U equals to 3x squared minus 5. And now we differentiate. We differentiate the U over the x will now give us the U over the x, means differentiate U with respect to x. So if we differentiate this, we have 6x. Derivative of a constant is 0. So the U over the x is 6x. But because we have U and we have x, we can differentiate when we have with respect to two variables. We need to make all of them to become one variable. So we can change this with U. We understand this can be replaced with a U. But we still have 6x and the x here. So we reshuffle this in a way that we can get rid of 6x and the x. How do we do that? Make the U the subject formula here. If we cross multiply, we have 6x dx. Now if we have this, what this means is we can replace 6x dx with the U. And we can replace 3x squared minus 4 with U. And then this gives us another different thing to integrate. Now 6x dx is now the U, and all the content of the bracket is U to the power of 6, and then we have the U. So we can now integrate this with respect to U. So it means that we have, if we integrate this, we have U to the power of 6 plus 1, 7 over 7. But remember that we have interval of 0 to 2, making it a definite integral. So now go back, just like we did with K method. When you are done, replace your U back. So this is our integral in terms of U from 0 to 2. Now let's go forward one more step. Now what this means is replace back, put back here U. If I put back my U is 3x squared minus 4 all to the power of 7 divided by 7 for the interval of 0 to 2. Now let's get the area under the curve or the value of after integration. Now this means replace the first one with 2 all over 7, remember the content of the bracket raised to power 7. And then this will be minus everything. We also replace x with 0. So we have 3 onto 0 all squared minus 4 to the power of 7 all to the power of 7. Now if we simplify this, this is 2 squared. 2 squared is 4, 3 times 4 is 12. 12 minus 4. 12 minus 4 is 8. So we have 8 over 7 all to the power 8 to the power of 7. 8 to the power of 7 divided by 7 minus 3 into 0 is 0, minus 4 to the power of 7 also. Now minus 4 all to the power of 7 or divided by 7. And this will give us, and our final answer will be 301,933,7. So that will be the area under this graph. 301,933,7. So this is the answer to this. Remember, the focus here is not even on the final answer, the focus is on the method. When we have complex situations, what do? We either use chain rule, which is direct. If you don't understand how the chain rule functions, change this to u so that you can integrate with respect to u, and then after you can plug it back in. It works faster. Even if you don't have the full or core knowledge of further studies mathematics, you can also use the knowledge of core mathematics and resolve this. Please continue to share, follow our pages, and subscribe to our channels. I'll see you next time.